Hey there, everybody. Dr. Yeager here, and today we're going to start our discussion over Chapter 13. Chapter 13 covers fluvial processes and is one of my favorite chapters in the book. And so let's get started. When you hear the word stream, you probably think about a little river. Streams generally, from a lay definition, don't include big rivers like the Rio Grande and the Mississippi and the Colorado and things like that. But from a geomorphological standpoint or from a physical geography point of view, the word stream covers everything from the biggest river down to the smallest little arroyo that is only fills up after a rain. Every channeled water, every channeled flow of water is referred to as a stream. Okay, so you'll hear me refer to the Mississippi River as a stream, and you'll hear me refer to little teeny tiny creeks as stream. They're all streams as far as we're concerned in physical geography. When you hear us talking about the processes by which streams shape and impact their surroundings, those are what we call fluvial processes. Anytime a stream or running water on land shapes the landforms around it, those are what we call a fluvial process. And there are two general types of fluvial processes that we'll talk about in this chapter. One happens as water moves across land, not in a stream. You can imagine raindrops falling on a surface of a hill slope and just running down the hill before they reach a stream down at the bottom of the hill. That type of fluvial process would be what we call overland flow, and we'll talk about that here in a few minutes. Once those raindrops make it down to the bottom of the hill and into a stream, be it a very small stream or be it a very large stream, the processes that happen in that stream that shape the land around it are going to be called stream flow. Okay, that's pretty easy. And as we're talking about all these processes, there's one sort of rule that we have to remember, and this is what I call the first rule of fluvial processes. We will hit on it over and over and over. We've actually already started hitting on it. We talked about it when we talked about chapter 11. And this first rule of fluvial processes is that water always goes down. Okay, it has to go down. Water cannot go up, right? Because water is subject to gravity just the same way as everything else is. So water always goes down. And this is normally when someone thinks in their head, yeah, well, what about if we pump it? Okay, or if there's a pump involved or some sort of human action that is lifting the water, that sort of supersedes the first rule of fluvial processes. But naturally, water always has to go down, okay? Well, how far does water go down? Well, it goes down until, it either gets to the sea, right? So water that falls here in San Antonio may make its way into the Guadalupe River and may eventually make its way down into the Gulf of Mexico, right? To where it gets to sea level, and it can't go down anymore. Or number two, it goes down until it can't go down anymore. Well, what level is that? Well, sometimes, as we're going to find, in certain places, water drains down into a basin, sort of a big bowl, where it's surrounded by mountains, for example, or it's just surrounded by higher land. And once it gets down in there, it can't go down any further. It's like when you're pouring milk, into a bowl. It goes down to the bottom of the bowl, right? And it can't go down any further than that because the bowl holds it in. So if you remember that rule of fluvial processes as we go through this, that's going to help you out quite a bit. When we think about streams and the landscapes that streams create, we can break this down into sort of a really simple way to think about it. There are high points and low points. Okay, there are areas that are up and areas that are down. that first rule of fluvial processes that we just talked about says that water, when it falls as rain, it may fall in the low parts, and if it flows in the low parts, it will do its best to flow to a lower area if it can, and if it falls on the high parts, then it's going to flow down into the low parts, right? Because all the land is just high and low. We call these low parts valleys, and if you think about what you know about that word, a valley is a low area, relatively low between two high areas. So valleys are the low areas, and interfluves. And interfluve is a German word. It's fun to say. I highly recommend you try saying interfluve. An interfluve is a high area between that surrounds a low area. So interfluves are the high areas, and valleys are the low areas. In a valley, let me move my picture here if I can. In a valley, organized drainage networks, things that we're going to learn are called watersheds, become established. Okay, this is where water flows into streams. If we look at this picture here, we've got our valley down here, which is clearly lower, and our high area, right, which is our interfluve. And if you look, there's another valley over here and another valley over here, and these valleys are separated by this interfluve. Okay, this is an area that divides these drainage basins. Drainage basins are the organized water flow area inside a valley, and these drainage basins are divided by high ground. Okay, the high ground is this area that divides these drainage basins. As such, we sometimes call interfluves a drainage divide. An interfluve and a drainage divide are sort of the same thing. When we talk about these organized drainage basins, we oftentimes call them watersheds. And a watershed is a word that is important for folks who live around San Antonio and all places where there's the potential for drought. Watersheds are areas in which every drop of water that falls in there is going to make its way out through one stream. It's like an area where there's only one door to get out for water that falls in. And so if we hypothesize that a water droplet falls here, that is eventually going to make its way down into this stream, and this stream is going to flow into this bigger stream, and this stream is going to flow into this largest stream, and that water droplet will eventually flow outward here. This is the only way out of this area, this watershed, for any drop of water that falls down through here. Okay. If we look at the San Antonio area, which is right here, you can see that these different colors represent different watersheds. And so you can see this is Bear County right here. You can recognize the shape. The college, Vista, is right over around here. And we're right sort of on the border between this pink color and this orange color. The orange color is the Leon Creek watershed, and this pink color is the Medina River watershed. So if we just say that Vista is in the Medina River watershed, that means that every drop of water that falls on the campus that isn't acted upon by a human-built drainage system or a sewer thing, or things that we build to divert water, every drop of water that falls there is eventually going to make its way into the Medina River. And then the Medina River is going to flow into the San Antonio River, because all of these smaller watersheds are part of the San Antonio River watershed. And then the San Antonio River will flow into the Guadalupe River. And then I believe the Guadalupe River flows into the Gulf of Mexico. So you see that there are lots and lots of smaller watersheds, like the Medina River, the Leon Creek watershed, the Cibolo Creek watershed. What other ones do we have? The Salado Creek watershed. So there are lots of little watersheds that are embedded within bigger watersheds, and the San Antonio River watershed is in the Guadalupe River watershed. And we're all of these are in the, or if you look at the United States as a whole, if you looked at like the watershed for the Mississippi River, it would be huge. It would, and probably encompass 40 states. But it's made up of lots of smaller watersheds within it. Within a watershed, if we look at how we organize the streams within the watershed, we would call this stream ordering, and it's a pretty easy thing. If we have a little watershed here, we would have a valley and interfluves. The valley is obviously the low areas where the stream flows. The interfluves are the high areas between the streams. So here's an interfluve here, right? Here's an interfluve here. Here's an interfluve here. Interfluve here. The interfluve is just the higher land, and the river flows through the streams. Every little teeny tiny stream that sort of starts on its own near the high point, near the drainage divide or the interfluves, is what's going to be a first order stream. These are going to be the smallest streams in the watershed. And you'll notice that the smaller streams join together eventually, and when a first order stream joins with another first order stream, it forms a second order stream. And when two second order streams join together, they form a third order stream. And when two third order streams flow together, they form a fourth order stream. Within a watershed, there are going to be lots and lots of first order streams and second order streams. There are going to be lots of them, but they're going to be really, really short, and they're not going to have much water flow through them. And but there are going to be fewer second order streams and third order streams and fourth order streams. As the order of the stream gets larger, the number of those streams in the watershed becomes fewer, but those streams become larger and larger and larger. So on this watershed here, there's only one fourth order stream, but this fourth order stream is much, much, much bigger in terms of how much water it's transporting than any of these first order streams or second order streams. Okay, if we think about within the Mississippi watershed, Mississippi River watershed, what order stream the Mississippi River is, I don't know what it is, but it would be a big number. And the Mississippi River itself is obviously a really, really big stream. Let's say, for example, it's a 20th order stream. Well, that 20th order stream is a big river, and there's only one of them in the watershed. There would be millions of first order streams in the Mississippi River watershed, but these are going to be really, really small, little teeny tiny streams. So there are many more of them, but they're very, very small in terms of magnitude. Okay, I'm going to stop there. We will pick up with the next video, and we will talk about overland flow, and so we will see you then.